I'm Invention.
And I'm Vidya.
And our product is AutoImage, and its function is to automatically detect cancer cells. So at the beginning of our journey, how we got here was that we first outlined the problem that we wanted to make the current research process for cancer more efficient. And basically, we arrived at this problem because we both have prior experience working in cancer research labs, and we saw that there was a lot of manual labor that needed that was a part of this research process, and we thought we could make it more efficient. So three broad ideas we started with was our first idea was to make the analysis of immunofluorescent stains more efficient. Our second idea was to make a machine that could automatically wash and stain cells, and then our third idea was to create a microscope that could automatically adjust scans to make the process of getting these images more efficient. And then so we utilized the decision matrix in order to narrow down our idea to one. And then so from here you can clearly see that idea number one was our winner, and then we decided to continue with this idea. So here we outlined the basic research process of immunofluorescent staining, and then from here we learned that the process of counting these cells from a single scan can take anywhere from 5 to 7 hours, and so we wanted to attack this area. And then so this led to our proposed solution of creating a program that automates much of the cell identification and counting process, and that also provides an avenue for researchers to share data with each other and utilizes machine learning to make it more accurate. So some existing solutions that exist today related to our product include ImageJ, which is a software program that allows researchers to manually count cells within it. And then there are some readers that exist today that automatically do this as well, but they can cost anywhere from about $50,000 to $3 million for a single machine, and are targeted toward these large pharmaceutical companies. And then we also referenced some papers that included circle transforms and edge detection algorithms to identify cells, and also a cell counting algorithm that was developed within MATLAB. And then so here's a picture of some of these readers, and then a little of some of the basics about our program. We utilized Java to write the code and used NetBeans as a compiler, and we also utilized OpenCV, which is an open source computer vision library.
So the first thing we did in developing the program was to create a flowchart that outlined the ideas that we wanted to implement. The first iteration of our program was an image threshold algorithm, which filtered out certain parts of an image. The second iteration of our program was a cell identification program, which basically took an image from a camera and fed it into the algorithm, putting the cells out in white and the background out in black. And the third iteration of our algorithm, as you can see right here, has improved the usability and the utility for the user, adding some additional features. And this is the last step we have before we start counting and collecting data from the cells. In terms of how our product is different from existing products, we have made it easily accessible and at no cost through the open source. Also, we have expanded the total addressable market, not only marketing towards big pharmaceutical companies, but also towards researchers all around the world. We have also made a platform for innovation, meaning that in the open source, anyone can add to our program, making it, again, more efficient. And lastly, we're going to enable sharing of data, which is going to let researchers reference different scans and collaborate using our program. In terms of market value, though this program is open source, we will still be able to generate revenue. This is going to happen through referrals and joint ventures with other companies. In addition, tech support is going to also generate some revenue. And most importantly, we have future benefits to society. Our program can be easily integrated with existing lab equipment. And I guess our final goal is to make sure that we make the research process more efficient. It is the hope that in the future, making this research process more efficient can eliminate the need or minimize the need for expensive procedures such as MRIs and biopsies. Thank you.